So as you can see, we've moved on with this mill cabinet. It's been quite a tricky build. In fact, it's taken a lot longer to get this far than I hoped, to be perfectly honest. So join me after the titles and we'll have a look at why this was tricky. I thought before I get into making the enclosure for this mill, I'd just show you some of the problems I've got. Firstly, it would be very easy to make it asymmetric, so that because the table, this is as far as the table goes this way, so I've got a little bit of a gap here between these mocked up verticals. On this side, because there's the stepper motor, I don't know if you can see that particularly well, but there's a stepper motor in there. At this side, then the table will go the same distance plus the width of the stepper motor, which means that you end up with a bigger piece this side than you do this side. Well, I've decided that I'm going to make it symmetrical, so I'm going to use that size of angled base on this side as well, so that it will look symmetrical, give me a little bit more space inside. Now, here's some of the difficulties. Firstly, the coolant if this is effectively the front of the machine here, any coolant that pools here won't be able to get past this steel support. So I think what I'm going to have to do is build some sort of angled interface here that's going to push the coolant down here and then underneath. And that's the next problem, because underneath, if I come around the side here, that's that tiny little slot that's available. I'm going to have to weld on a chute underneath here so that it guides the coolant into the coolant tank, or the bucket, which is yet to be decided. I'm not entirely sure how I'm going to do that just yet, but there will be some sort of bucket here with the coolant pump in, and also an aquarium pump, and we'll come to that in the future. On the sides, right, back to the front, let me see if I can get a piece of wood here. Here we go. What I'm going to do is, there we go, going to put some angled chutes either side so that the coolant and chips will flow straight down and hopefully into the coolant tank in the bottom there. That's easy enough to do on both sides. Here we go, here's the other side. That's relatively easy to do. I need to just make sure that the top of this slopey bit clears the bottom of the stepper motor, then we're golden. So moving on, this is I think the trickiest bit. This machine has got the electronics, let's go and open it. The electronics is in a cabinet on the back, as I'm sure you've seen before, and it's a bit of a weird design if you ask me. All this is relatively straightforward and relatively simple, XYZ and the fourth axis. Here's a little breakout board for the various steppers, so you can see there's the stepper drivers. They're plugged straight into that breakout board. This is VFD for the spindle motor. Here's the power supply. That's a beefy transformer, that is, to drive these stepper motors. And down the bottom here we've got some circuit breakers, a little bit of LCD. This is LCD contrast adjustment, and I don't quite know why that's down here, because the LCD is on the top of the machine around the front. Anyway, that's by the by. There's an inlet filter there just to take any spikes coming in from the mains, and also to stop spikes going back out from this machine. And down the bottom here I fitted these, which are wired to here. They are the brake resistor, so when you hit stop on the spindle, the excess energy is dumped into these resistors, and it stops the spindle quickly. On the side here we've got the connectors and the main switch. So the connectors, whoops, get it out of the way, that's where the power goes in. The connectors go to, that one goes to the stepper motor for the x-axis, and the other two go to the limit switches, the two limit switches. That's a really poor design, but yeah, we won't worry about that for the moment. I may change that in the future. But here's the issue. Oh, blimey. Now I'll go around the other side. It's easier to see on the other side. Oh, I forgot. In the top here, that in there is the CNC control board. That's a really weird place to put it. I guess they put it up here because effectively it's in its own little box. So it's got a bit of a Faraday cage that stops electromagnetic interference. Also there's a little power supply in there too. A little 24-volt power supply to drive it. Right, so over on this side, the head goes up and down, as is the case with milling machines, and this piece of steel here goes inside this case and is joined to another piece, the other side of the head, and then the ball screws attached to it. So that slides up and down this slot, and if I go to the front you'll see this, you can see there's a slot either side. There you go, you can get a finger in there, get a finger in there. That's fine and dandy, except I can't seal that for chips and coolant, so I now need to make sure that I'll give you a demo. If I see, I could cut a piece of wood, and will do, cut a piece of wood to fit here, and then angle it and fit it quite tightly around the base of the machine there. So that'll stop most of the chips and the coolant. However, the problem comes here because the chips, because I can't seal this gap, the chips will fall and form in the back here, inside this cabinet. So they will drip down the back, and that's where the problem is, because I'm going to have to build some arrangement that in here on the base that seals against the back of this machine and allows the coolant to flow underneath. And oh, if I can go underneath, yeah, to flow on. I don't know if you can see that underneath there, and then come out and into the tank. That's tricky. What would be a better solution, I thought, would be to there's two screws, one either side of here, and I think, now I'll show you that again. In here, right at the bottom, you probably can't see that particularly well, but right at the bottom is a hex screw, another one here. That holds the bottom of this case in place, and I think the top, there's no screws in here to hold it in place. I think the other two screws are just these two on the top here. So I could loosen this case off and move it back. I could move it back a considerable distance, but I've been thinking about it, and because whatever happens, I can't seal these holes. Even if I moved it further back, I still can't seal them. So I think the best bet is to leave it where it is and come up with some fancy bit of ducting underneath here to move the coolant back into the tank. So yeah, that's the difficulty. That's what's been holding me up with this machine. Trying to get my mind around what to do. Oh, I must show you this as well whilst we're here. This the head on this machine is not counterbalanced. It's supported on a gas strut, and as you can see, that's knackered for two reasons. Firstly, it's upside down. I think they should go the other way up so that the oil that's in here seals against the piston. This way the oil runs down to the bottom away from the piston, so it's going to leak. And also, if you look at the top of it, I really don't know if you can see this at all well, but you see that? That screw? That's bent. Right, here it is. No gas in there whatsoever, and look how mangled that is. Excuse the bad audio of this, but I just thought I'd show you how useful one of these laser levels is to mark out something like this. I'm cutting out this back panel. What I've done is I've lined the laser up with the edge of the panel I need to cut and projected it all the way up to the bottom of that panel. So effectively I can mark that and then cut out the triangular piece here, and that panel should slot down nicely. I've had a delivery. These are some of the parts I need for the mill. So let's have a look and see what we've got. You could ride bare ass to York on that. That's as blunt as anything. Right, at last. That was a struggle. That is the gas strut, replacement gas strut for the mill. In here should be the filters. There we go, that's the first one. That's the mesh filter, or the first mesh filter for the chips. And in here should be another one. Oh yeah, definitely finer. Look at that, my word. I thought this would be too flimsy, so that's why I got two different sizes. So that the bottom one, thicker one, will help support the top one. Yeah, let's try those out, make sure that we can get water through them. There we go. There we go. That is laminating resin, and in here the catalyst and a syringe to mix it with. So yeah, that's good. Put that over there, out of the way. Actually, I'll tell you what, I don't know if this stuff is light sensitive while it's like that, so I'll just put it back in its box. So moving along, this should be the cloth, glass fibre cloth. Ooh. Right, there's 10 square metres of cloth there, and chopped strand mat. And as I've not done any proper glass fibring ever, apart from repairing the odd panel on a car, in here should be, that's the surface tissue that's going to go over the top of the chopped strand mat. And that in a minute. There you go, I bought a tool kit, so I've got all of the bits I need, including another resin. Yeah, another thing of laminating resin. Oh right, I had plenty of this anyway, but there's acetone for cleaning stuff up, mixing cups, catalyst, and another syringe. So yeah, all told I have enough stuff to put this together. I bought a pump, an aquarium pump. I have, and I'll drop in a shot of the actual thing, a semi-industrial hobby use coolant pump. But one of the problems I've found with my machine over the years is that cleaning it down has been an absolute nightmare. So I bought a little aquarium pump to put in the coolant tank. No idea if it's going to survive or not, but this will pump coolant through a hose to wash the machine down when you're finished with it. And with that in mind, I bought a few meters of pipe to do that. So, oh, that's nice and flexible. Oh, I like that. This is 1,000 litres an hour, and it can pump a head of just over or just under 1.5 metres. So from the coolant tank to the top of the machine is about 1 metre. So we should be more than okay to do that. And finally, this morning I picked up 2 of these. These are the lights for the inside, the enclosure. Tiny little 10-watt LED IP rated lights. Now, the only problem with these is some of these LEDs flash. So I need to test with a camera whether or not they're going to do the job. So here we go. Plug that in. Well, it works. Here's a tip. If you have to touch something that's metal and you don't know whether it's live, touch it with the back of your hand. That way, if it is live, your muscles will contract and pull it away from you. Or you'll pull yourself away from it. If you go like this, you could grab onto it and kill yourself. But touch with the back of your hand, you're safe. It'll still hurt. Believe me, it bloody hurts. But there you go. Okay, I need to get a camera and do some test footage with that. So here we go. This is some test footage with my standard SLR camera. I will also just get, there you go, I'll get my little GoPro that I use for, there it is, that I use for slow-mo shots and time lapses. And we will see whether or not this footage is flashing in the edit suite. I have to say it looks alright so far. There we go, with two of those LED lights, one the other side as well. We should have enough light in here to do stuff. It might be a good idea to put a little targeted light on the bottom, sorry, on the head, but we'll cross that bridge when we get there. Yeah, it looks good. Right, I've been thinking about this for the last few days. This has been concerning me, how to do this, because ultimately this cover needs to come off so that you can get into this machine to maintain it. For instance, if the Z-axis stepper motor fails or a wire breaks, then I have to actually get in behind here, and that means taking the whole thing to pieces. And the same is true with the Y-axis. That's buried in the bottom there. So I need to be able to remove the top half. So I think what I'm going to do is do it in two halves. I'm going to have the top half that sits here with some sloping sides that just get into the hole, if you like, on the top of this. I'm not making that very clear, but and underneath in the actual base, I'm going to put another chute as a completely separate item. So effectively, these top halves can be unbolted. They're only going to be bolted on, so they can unbolt and come off, and then I can get access to the machine to work on it. So I think that's going to be my best bet. It's a bit of a fiddle, but yeah, let's get on with it. I think the next thing is to just get these tops so that they're all square and bolted together at the top. Then I can take them off, lift the machine off, then work on the chute underneath. So it's a bit of a palaver, but we'll get on with it. That side is still square. Let's try this side. That's close enough for me. Quite wibbly wobbly. It is another day, and I've been sleeping on what I thought I was going to do with this cabinet, and I've changed my mind. I've got two of these drawer slides that, excuse the voice, I got a cold. Fitting them on the inside of this cabinet and attaching the windows to the sliding portion means that I can end up with about a 600mm wide, 2 foot for our American friends, opening to get my head in. And I've put a couple of boards up here and made sure that that's enough space for me to get in to load the machine, unload it, clean it, and all the paraphernalia you need to do. However, I've been thinking that the problem with this is these boards are about 19mm thick, and so there'll be a vertical one here, and then there'll be a big skinnet with thin ply on the outside. So there's an obvious area to trap chips and stuff
on the inside. So I thought actually it would make sense to replace the whole panel, this piece, the vertical and everything else, with a piece of ply. Absolutely fine. The only problem is I have got no ply that's thick enough to get an insert in. This is an M6 insert. What I want to do is in the very top here, this panel comes off. This panel is a separate piece because what I'm trying to make here is both halves of this clamshell come off so that I can get in to maintain the machine should I need to. And that means that for rigidity I need to put an M6 or a threaded insert in there and a bolt through the top. However, I can't get that in this thin piece of ply because it's only 12mm ply. So I have a plan. I'll bring you in close and show you. Hopefully you can see this. That M6 insert will blow the sides of this ply out. So my cunning plan is to put this in the lathe, take the fins off, make it parallel and epoxy it in. It doesn't have to cope with a massive load, so we should be alright with that. Honestly, you need 3 people to do this job. One to put the clamp on, one to hold the wood, one to make the tea. That side is perfectly vertical and square. This side is out by about 3mm, an eighth of an inch. Not going to worry about that. That's close enough for me. Hopefully this should just pop straight in that hole. Yeah, I'll buy that. That's pretty nice, to be honest. Looking good, looking very good. Let me explain what I'm going to do. These draw slides are going to be fixed on the inside, on the inside at the top here, and they're going to fit obviously on the other side, but there. And I've put a mark to show where they actually close up to, and the door will be attached to here, so it will slide and give me that much. That's the centre line, and that's how far they open. So the problem I've got is I don't know exactly how I'm going to finish this this cutout, because I've got to work out how to make the 2 halves of this clamshell come apart. So anyway, this is what I'm going to use. This is I think I'm going to use this. This is pine from an old bed, a single bed that I think I'm going to cut down and use as a lipping. If I don't, then I've got some hardwood that I can use. So hardwood's probably a better option, to be perfectly honest. But anyway, I can't work out exactly how I'm going to fit this until I've worked out the bit at the bottom here. So the next step, I think, is I know that this board can't be any longer than that mark, the length of the slide. So if I slice it down all the way to the bottom at that width, then in fact it might be sensible to put a joggle in it, across there. Yeah, let's do that. I can always take more off. So I'll come down to the height of the table, which is about there, plus a little bit more, so we'll go down to about there, and then we'll go across and then down. There's the natural join for this clamshell there, so it would make sense to make this finish at that point. I must admit it's been a bit of a revelation just how useful these laser levels are. I'm lined up with the mark there for the full width of the slider, and that should be a vertical line, and the horizontal line I've put, you probably can't see that very well, but it's just at the height of the bellows on this table. So I've got a little bit of space, because you can actually bolt things on the front edge of this machine. It makes sense to give yourself a little bit more space. So that should be the shape I want to cut out. I want to cut this piece out here down to there, and then vertical up to there. Perfect.
Well, if you made it this far, thanks for watching. Please hit the like and subscribe and the bell notification. That'll let you know next time I post a video. And as you can see, this is a little further on than in the rest of the video. I've actually started to mock up the chutes underneath, and I've got the angles right, I think. So we're getting there. It has taken longer to do than I hoped, and it has been quite a tricky build. Mainly because of the design of the back of the mill. I have to make this so that these halves come off. So this panel here comes off, this tie bar, the tie bar at the back comes off, and then these two sides literally strip out so that I can work on the mill should I need to. It's been a bit of an odd design. Anyway, more to the point, thanks for watching. Join me next time when hopefully we'll get a bit more of this done. And yeah, I appreciate you watching. Take care, and we'll see you next time.